that the axial load or the stress due to axial load is uniform. Then now you have minus, now it's 23.262. Now you have to take, so 8.154, the entire structure is 20. So point D relative to the centroid is equal to 20 times 10 to the power minus 3 minus by 8.154 times by 10 to the power minus 3, and then divide by 3.88 times 10 to the power minus 9. Okay, so this will be equal to 20 power minus 3 minus by 8.154 power minus 3 times by 23.262 divided by 3.88 power minus 9, and then 3.846 power 6 minus by the band. So it's minus 67.175. Okay, minus 67.175 times 10 to the power 6 Pascal. Okay, so we have found our position for our stresses at point A. I do apologize. This is in fact point D. Okay. Then the question even further asks us to determine. Okay, so let's go back to the question. Asks us to determine the location of the neutral axis. Now, the location of a neutral axis is in fact very easy to find for this case. It's not as complicated as when we were doing eccentric unsymmetrical loading. Okay, so there are two ways that you can deal with this. You can do it based on the formula, or I can teach you a easier way. If you cannot remember the formula, you can use the easier way. So I'm going to show you two ways. Okay. So if you're going to apply the formula, right? So at the neutral axis, right? Stress X is equal to 0. Okay. Stress X is equal to 0 at the neutral axis. Then you just need to write down stress X is equal to P over A minus by mz over izz multiplied by y. Okay. So at the neutral axis, this is equal to 0. So you have P over A, or Px over A, I do apologize, minus by mz over izz multiplied by y. Right? So you have, so now we are going to find y. Okay. So we just shift the equation Px over A. So this is equal to mz over izz multiplied by y. So y is equal to px over a izz over mz. Okay. So we just plug in the formula. So we know px over a, we know that the value is equal to 3.846 times 10 to the power minus 6. 3.846 times 10 to the power minus 6. izz is equal to I told you guys my memory is so bad now. 3.88 times 10 to the power minus 9. Okay, 3.88 times 10 to the power minus 9. And then if we were to determine mz, okay, so mz you can see over here is going in a clockwise rotation, right? If you take relative to AA, right, it's going in a clockwise rotation. So when it's clockwise, it has to be equal to minus minus what? Minus, so mz is equal minus 23.262. 23.262. So you have to remember your vectors down here, okay? It's mz is equal to minus because if you look relative from point A, right, relative from AA section over here, this rotation is in a clockwise rotation, so it is negative. Okay, so finally, this will be equal to 3.846 power minus 6. That's by 3.88 power minus 9 divided by 23.262 is equal to minus, I get minus, wait, 3.846. 3.846. This is positive 6. Come on, Eugene. So 3.846 power 6 times by 3.88 power minus 9 divided by 23.262. So it's equal to minus 0.641. Okay, I get minus 0.641. Okay, times 10 to the power minus 3 meters. Okay, so you can use this technique purely based on formula. You have to remember that your moments, okay. Now, what if you can't remember? Okay, if you can't remember, there's a very easy way to do this. Okay, and I think it's important to know what is a simpler way. If you cannot remember, there's an alternative. I don't want you to like panic. Okay, so what is the alternative? Sketch. The alternative method is sketch the normal stress or stress X distribution profile. Okay, just sketch. It's that easy. Okay, and you only need to apply high school math. It's that easy. You just need to apply high school math. Okay, so we're going to literally sketch it out. Okay, so we're going to have our x-axis. Okay. So this is our stress X. So if you look at our value, we have the extreme. You have 52 and 67 minus 67. So I'm going to start with minus 80, minus 60, minus 40, 20, 0, 20, 40, 60, 80. I think this is more than enough. Okay, so this is our normal stress X. And from here, we sketch our, or we have our vertical axis is your Y. Right. So 0, 2, 4, 6, 8, 10. This is your Y. Minus 2, minus 4, minus 6, minus 8, minus 10, and I'll go up to minus 12. Okay. Then we know that when it is at 8.154, right? So we go back here. If it's 8.154 at the top, we are going to get a tensile of at point A is 52.732. Okay, so 52. So you just eyeball it. So 8.154. So this is 50, 52, 8.154. So it's somewhere around here. Okay, 8 point. So you will put down here. This is where you have your 52 point. Let me see, 52.732. And then 8.154. Okay. So this is in megapascal. and this is in millimeters. Okay, and then the next point is at 20 minus 8.154 is 11.846. Okay, so that point is 11.846 and 67.175. So 67, okay, and 11.846. So this is 1267. So it's somewhere around here. Okay, as I say, this is eyeballing. So we know that this is 67.175 and 11.846. Okay, so we just draw a straight line. And this straight line, the neutral axis should be below, right, the zero line. Okay, and as I say, this is eyeballing. And it's true, it did not pass through zero, right? Or it did not go to the center. And from the sketch that we have done, we know that the centroid is down here. Oh, sorry, the neutral axis. So this is the position of our neutral axis. And over here, this is our centroid. So we know that. So now if the question were to ask you to sketch the, so this is the sketch of the normal stress of the profile. And then below is going to go to compression. Right? So from here, we can use a very simple method to find where the y or the position to the neutral axis is. Okay, so we know that the function is y is equal to m stress x plus c. Right? It's a you can see it's a linear function. Okay, so to find the gradient m is equal to change in y divided by change in x, right? So change in y, I'm going to take the whole thing, the change in y, the whole thing is 20 millimeters. The change in x will be equal to what will be equal to 60 or equal to 52.732 minus by minus 67.175. Okay. So this will be equal to 52.732 plus by 67.175. Okay, so 20 divided by, so it's equal to 0.1668. Let me do it again. So we have 52.732 plus by 67.175. 20 divided by that is equal to 1.668. So that is the gradient. So next we just need to, so this is y is equal to 0.1668 stress x plus c. Okay. So we are going to substitute when stress x is equal to minus 67.175. Okay. Y is equal to 11.846 to determine C. Okay, the y-intercept. I know this looks a bit longer, but if the good thing about this is you don't need to remember whether this is positive or negative. Or if you panic, oh, I don't know positive. This is a very straightforward method and you can't go wrong, I hope. So you have 18.846 is equal to 0.1668 multiplied by minus 67.175, and then you have plus C. Right, the gradient is positive. So 11 11.846. So sorry, this is minus 11.846. I do apologize. That's why I say like, oops, there's something wrong. So this is minus 11.846. There's a minus sign down here. Okay, there's a minus. Let me write this out better. It's a minus 11.846. Okay. So therefore C is equal to minus 11.846 plus 67.175 times by 0.1668, 68.1668 times by 67.175 is 11.205, right? So you get minus 11.846 plus 11.205 is equal to minus 0.641 millimeters. Okay. So if you look at our values, yeah, it is spot on. Is exactly the same. Both technique works. Okay. So usually if this question will come out, if they ask you to sketch already, okay, if you forget the formula, you cannot remember there's a minus down here, you cannot remember MZ, is it positive or negative, just use this method. Okay. High school students can even do it. Okay, you don't need to go to this course to do this. Okay, any questions so far up to here? Anyone, please? Okay, if no, I'm going to stop lecturing here. Now, anyone have any question regarding the homework, please? Any question? I will stop lecturing down here. If you ask me about the lectures, I think we are like probably 1 day ahead compared to normal time. Any question for the homework? Anyone that tried the homework and you have issues? Anyone, please? Lucia, you say no. Anyone else? No? Okay, if that's the case, I'm going to stop the class now. Okay, I'll still be here if you have any question with your homework. And tomorrow at about the evening time, I will post quiz number 1, and it will be off from homework 1 and homework 2. And it is going to be due, like what I said, it's going to be due on. Oh, sorry, I'm going to available on May 16. Okay, not tomorrow. I do apologize. And it's going to be due on May 20. Okay, so you have to know how to do your homework 1 and homework number 2. Okay. Anyone, any questions from the homework or any difficulty from the homework? Okay, if no, as I said, I'll still be around. I'll stop recording first.